check out things. Sometimes I also do recording, but not mostly because my computer gets loaded with the, the sessions, so it becomes difficult for my laptop to move on. Okay, so this is question number 5. Anything which is not clear here?
Nope. Let's go down that part.
Next one.
The next one that I had questions with was number 11 and 12, 13. So all three on
Yep.
that page.
Did I showed you how to solve these on the calculator?
Yes, you did.
Great. Because you have to use the calculator for that. Okay, going to number
11 first.
11. All right. So for 11, we are revising the rules of exponents. If we know the rules of exponents, we'll be able to do all the things which are related to the exponents. Now let's go to the first rule quickly. That is, rule of, when you're having exponent means, for example, 2 raised power 5. 2 raised power 5 is the shortcut form of writing 2 times 2 times 2 times 2 times 2. Simple. So if you want to write 2 multiply 2 5 times with each other, with itself, then you can simply write 2 raised to the power of 5. Now, if you want to multiply 2 raised power 5 to 2 raised power 3, that means you're multiplying, 5 2's with 3 2's. 2, 2, 2. That's 2 raised power 3. And 2, 2, 2, 2, 2. That's 2 raised power 5. Now, how much will that be? They are in total of 1, 2, 3, 4, 5, 6, 7, 8. There are a total of 8 2's now, 2 raised power 8. So when you're having, exponents in multiplication with same bases, when you have an exponent, you'll be having two things. One will be the base, another will be the power on the base. So when you're having same bases in multiplication, then you'll keep the base as it is and add the powers. So 2 to the third times 2 to the 5 is 2 to the 8. In the same way, 2 to the 10 times 2 to the 15 will be 2 to the
25th.
right. So that is the power of, when you're having like bases and same bases in multiplication. Now, if you're having same bases in division, like 2 to the 10 divided by 2 to the 3, you'll be subtracting the powers. That's 2 to the
7th.
correct. You can even write this on the calculator. You can raise power something, to this 2. Raising power is here, which is arrow pointing upwards. 2 raised power 10, and then divided by 2 raised power 4. You'll be getting 64, and that 64 you can think of like it'll be 2 to the 6, because you can, 2 times 2 is equal to this times 2 is equal to this, so 3 2's. And then you can go on multiplying, and then you'll be able to check how many 2's you'll be multiplying to get 64. That is 6 2's, so that'll be 2 to the 6. Anyways, if we want the calculations of these, that is the second rule which we have, the division. When you're having the third rule is related with the power raised to the power. For example, 2 to the 10, and that is raised to the power of 5. You will multiply the powers. That'll be 2 to the
50.
correct. Now, you're having x to the 8, and you're having x to 24. What you will do to this to get this?
You raise it to the power of 3.
Exactly. You raise it to the power of 3. If you do it on the left side, you have to do it on the right side also, isn't it? Because whatever you do on one side of the equation, you have to do the same thing on the other side of the equation. So if you raise power 8 to the 3, the rule says you'll be multiplying the powers. So it'll be x to the 24 But what will be on the right side?
6,
2 times 2 times 2. Can you check that out? How much is
8.
that? 8. You're done. Is that clear?
Yes.
So 3 rules you have to remember and you have to apply. What about if you're having x to the 0th power?
It will be 1.
Exactly, which I perhaps told you last time. If you're having negative power, x to the negative 2, that can be always written as 1 divided by x to the 2. It's the same thing. When you're having negative power, you can change the position of that. If that's in the numerator, write that in the denominator with a positive power. And if that's in the denominator, for example, 1 divided by 2 to the negative 5, you can write that in the numerator with a positive power. Okay, so whenever you're having any negative power, you can make that positive by changing its position. If it's in the numerator, write that in the denominator. If that's in the denominator, write that in the numerator. You'll be making the negative positive. Got it?
Got it.
And opposite is also true. If you're having a positive power, 2 to the 10, you can write that 1 divided by 2 to the negative 10. Simple. They are both equal. Now I'll be giving you here one question. X to the 2 times 2 to the x times 2 to the x again. So divided by y to the 5 times x to the 20. Can you try to solve this and tell me what you'll be getting?
So does the 2x, would that equal like 2 times 1?
Why 1?
Because x, I thought x was equal to 1.
No, we are not taking x as 1. We are
Okay.
having 2 raised power x times 2 raised power x. So we know that when we're having same bases, we'll be doing what?
We'll be adding it.
We'll be adding the powers. So forget about everything. If you just focus on, you know, these 2 raised power x times 2 raised power x, what you'll be doing is they are in multiplication, you'll be adding the
Or
power. So
x squared.
that means multiplication. We are adding it, right? We are keeping the base as it is and adding the powers. X plus x will be,
X squared.
are you sure? X plus x, 1 plus 1 will be,
2.
or one apple plus 1 apple will be,
2 up.
1x plus 1x will be,
2x.
correct. It will not be x squared, it'll be 2x. Are you following? Because addition and multiplication is different. If you're having x times x, that'll be x squared. But if it is x plus x, that is, you're adding 1x plus 1x, that's 2x. Now, so that, what should we write here now?
X squared times 2x.
Why x squared?
Because there's an x square in the front.
Forget about that. I'm just talking about these two.
Oh, would it just be 4x?
4. So you're multiplying 2 and 2? Yep.
Yeah.
Okay. Let's revise the exponents. What I told you is, if you're having 2 raised power 10 times 2 raised power 5, you're having same bases in multiplication. What you'll be doing?
Just adding the exponents.
You'll be keeping the base as it is. You'll not be multiplying the bases. You'll be keeping the base as it is. If it is 2, 2, you'll be writing 2. And then adding the exponents, 10 plus 5, that's 15, correct?
Yep.
Now, if I'm having 2 raised power a plus 2 raised power a, you're having same bases in sorry, not plus, it's multiplication. 2 raised power a times 2 raised power a. So you'll be keeping the base as it is, and you'll be adding the powers a plus a. That's how much?
2a.
Correct. Now, if you're having 2 raised power x times 2 raised power x, what you'll be having?
2x
You'll be keeping the base as it is and then adding the
2 to the power 2x.
correct to the power 2x. You're right. Are you following?
Yeah.
So what I can do is I can eliminate this thing and I can write 2 to the power of 2x there. 2 to the power of 2x. Now, what else can be done here? Are we having any other bases which are same in multiplication or division?
There's x to 20.
And x to the 2, but they're in
Yeah.
division. So you're having same bases in division. What you'll be doing?
Dividing it.
They're already in division. So how to solve them?
Would it be
How much will be x to the 2 divided by x to the 20?
x to the 40?
So you're multiplying again 2 and 20, right?
Mm-hmm.
What does the rule say when you're having the exponents in division?
Oh, you subtract.
Right.
So it would be 2 minus 20, or could you do 20 minus 2? So would it be negative?
Subtracting the top minus bottom, 2 minus 20.
So it would be x to the negative 18.
Right, it'll be x to the negative 18. I can write this on the top. It's x to the negative 18. So this will be the simplified form of it, because we cannot do further because all the bases are different. One is having 2, another one is having x, another one is having y. So we can keep it as it is. But can you convert x to the negative 18 into positive power?
Yes.
What should we do?
Flip it over. You put the 1
Yes,
on top.
you'll be putting it in the denominator with a positive power. Simple.
And then you don't need to put the 1 because there's the.
Because there's already 1, so doesn't matter. Is that okay?
Yes.
Can you try one more? Can you solve this?
Yep. So I got a3x divided by b3y times 2 to the 6th power.
2 to the 6th power, we're having 2 to the 5
Oh,
divided by
there
2
was
to
a 2 to the 5th. I didn't see that one. Let me do that one real quick.
the
So I got a 3x over b 3y times 2 over 1.
2 over 1. What does that mean? Like 2 raised power 1?
Yeah. Oh, sorry,
Where,
not yeah.
where is that? Is that 2 raised power 1 in the numerator or denominator?
The denominator, because I turned it positive.
Wonderful. I was going to say that question next, but you have done this already. Good. Because the answer will be actually 2 to the -1, and then you can put that in a positive power by changing it to the denominator. You're right. Good. So
Will they
that
take
is,
off points for that if you change it into a positive?
it depends on, like, which question you're having, because it depends on the options, right? Sometimes you're
Yeah.
having negative power, sometimes you're having positive power. So you should be knowing the transformation. That's why you'll not be then stuck.
Hmm.
You got it? Because we don't have any, school type of or college type of calculations that we have to give each and every step. If we know some shortcuts, if we know some strategies, we will be applying them. We'll be even using the answers for getting the question, for getting the right answer, to just score well. We don't need the process of exact calculations which are done in the school. That we need to forget about SAT. We are having, some different stuff here. And that's what they see in the student, like how he can think outside the box, and how we can, have some creative thinking by using some maybe answers or some other stuff, or some, make it real, or plugging the points and getting the answer. Otherwise, in the school, you need to show each and every step. That's what we don't need to do here. Is 12 also to be done, right?
Yes.
Right, okay. Uh, okay, before going for 12, since we have understood about the exponents, now we'll be doing a little bit about square roots and cube roots. For example, we always write, sometimes like square root of 4 is equal to how much?
2.
2. You know why? Because square root means actually raising power 1/2. And 4 is actually 2 square, correct? And
Yes.
2 square is raised power 1/2. So how much, because you're having the third rule of exponent, when you're having power raised to the power, you'll be multiplying the powers. 2 times 1/2 will be how much?
4.
Are you sure? 2 times 1/2, is that 4?
3.
2. 2 times 50 cents.
Would it just be 2?
But 2 times 50 cents is $2. You're having
$2.
two, you're having two 50 cents.
Mm-hmm.
That's $1, right?
$1.
Yeah, but because you're multiplying 2 with 1/2, right? So 2
Mhm.
multiplying with 1/2, what you can do is you can multiply numerator with the numerator and denominator with the denominator. You'll be getting 2 divided by 2, that's 1 divided by 1, that's 1. So 2 times 1/2 will be 1. 3 times 1/3 will be 1. 4 times 1/4 will be 1. Is that right?
Yes.
Should I repeat it again? Any
No,
con
I
any
got it.
okay, great. So how much would that be then? 2 square raised power 1/2.
It
How
would
much would
just
that
be
be?
2.
2, it'll just be 2, correct. Now if you're having like 8 raised power 1/3, or I can say 8 can be written as 2 cube, 2 cube raised power 1/3. How much would that be?
2 point something.
You are using the rules of exponents, right? 3 raised to power 1/3. Like 3 is raised to the power 1/3. What will be the rule here?
To multiply it.
So multiply 3 to 1/3. How much will that be?
1.
1, right? It'll be 2 again. 2 is for 1, or you can say 2. Yes or no? Should I repeat it?
Nope.